Floral diversity is among the most common measures of assessing ecological soundness of a given ecosystem. A healthy ecosystem is typically diverse as it can host a wider variety of life forms that contribute to the processes of the entire ecosystem. Establishing a baseline information on floristic composition is an important step for a sustained effort to monitor vegetation dynamics for an effective biodiversity management system. The Runruno Gold Molybdenum Project, operated by the FCF Minerals Corporation, with its 3,092 hectares of mining forests in Runruno, Quezon, Nueva Vizcaya, Philippines, is taking a step to determine the floristic composition of its project area and to be able to monitor their floral restoration efforts by establishing 2 long-term ecological monitoring sites within their area. One plot represents the site's natural forest cover, while the other one represents their forest rehabilitation efforts.
Isa sa mga pagsasaliksik na isinasagawa ngayon ng FCF Minerals ay ang pag-implementa ng Biodiversity Monitoring System, kung saan ang layunin nito ay mapanatili at mapagpatuloy ang pagkonserba at pagprotekta ng mga likas na yaman, lalong-lalo na yung mga karating na kagubatan ng kumpanya sa loob ng FTAA.
This study uses a combination of traditional and new methodologies such as ground truthing, actual plot establishment, field inventory, mensuration, and geotagging combined with geographic information system and remote sensing, particularly the use of UAV and photogrammetry for efficient and improved visualization.
At kami po ay naatasan ng FCF bilang bahagi ng kanilang programa sa environment na magsagawa ng isang biodiversity monitoring system gamit ang GIS and remote sensing. So ang GIS po ay isa sa mga makabagong teknolohiya na ginagamit. Ibig sabihin po ay Geographic Information System upang magkaroon ng mas malinaw or mas epektibong baseline information pagdating sa kanilang mga pagdating sa kalikasan or environment. So ang layunin po ng aming grupo ay establish ng permanent biodiversity monitoring plots.
Through GIS and remote sensing, we conducted land cover mapping using free satellite data. In this case, we used Sentinel-2 multispectral image taken on May 5, 2019 to map the land cover in the project site. All satellite image reprocessing and analysis were done in Google Earth Engine environment. The processes are free and efficient. Accuracy assessment shows an overall accuracy of 96.76%, suggesting a good model performance of the random forest algorithm. Large part of the FCF site are still classified as forests, covering 73% of the total area. This updated land cover map was used to identify and visualize the 2 long-term ecological research plots for biodiversity monitoring and to model the carbon storage in the mining claim. The identified 2-hectare plot for natural forest is characterized by relatively steep slopes and with dense vegetation mostly composed of large trees. The BMS plot in the natural forest must be free from human disturbance and must be easily accessible for regular and continuous monitoring. The 2-hectare plot established for the rehabilitation area is located within the Malilibeg dump site mine rehabilitation area planted last February 2016. The rehabilitation area is planted with both tree and grass species as erosion control. The ecological research plots established has a total area of 2 hectares, subdivided into 50 20 by 20 square meter subplots to facilitate forest inventory methods. On the ground, the southwest corner of the 2 plots were marked by a 2-meter diameter orange PVC pipe. Then, each southwest corner of these subplots were marked with 1-inch diameter blue PVC pipes. Within each subplot, all 3 species greater than 5 centimeters were measured, tagged, and recorded. Individual tree location is likewise noted to later model each site's spatial tree distribution. Using drones, aerial images were collected for the two sites. Aerial images are processed to produce the desired outputs using photogrammetry software. The images are aligned and mosaiced together like fitting a puzzle until a lone image covering the entire area is created. These orthomosaics will be used as baseline data for the future aerial missions for the annual monitoring of these ecological research monitoring plots. These are high-resolution images with pixel size of less than a meter, which are suitable for detailed monitoring and analysis. A total of 119 species, belonging to at least 32 families, were recorded from both natural and rehabilitated biodiversity monitoring sites. There were 746 individuals belonging to at least 85 species within the natural forest plot, while 261 individuals belonging to at least 9 species were recorded from the forest rehabilitation site. Balobo is the most abundant species in the natural forest plot, followed by hagimit and white lawaan. These 3 species comprise over 30% of the individuals collected within the natural forest site. Vegetation within the natural forest site is dominated by pole-sized trees ranging from 10 to 20 centimeters in diameter and 5 to 15 meters in height. These indicate that the natural forest site is a relatively young regeneration of its former forest cover. However, since this area was left untouched, the forest regenerated without human intervention. Nara and acacia are 2 most abundant species in the rehabilitation plot. Lack of variety in the species composition is primarily due to the fact that the plot is in a rehabilitation site where species planted are limited depending on the plantation management. Forest rehabilitation site is dominated by seedlings with 2 to 3 centimeters in diameter and 1 to 2 meters in height. Larger saplings at 2 to 4 meters high are also present, while plants exceeding 5 meters is rare, since the plantation is only 3 years old. The Shannon Diversity Index for the entire natural forest site is computed at 2.28, while the forest rehabilitation site garnered a value of 1.51. Understandably, the natural forest has higher species diversity index than the forest rehabilitation site. The forest rehabilitation site is composed only of several species, mainly because its main purpose is for protection and not species diversification in that specific area. Annual monitoring using the same technique of using both GIS and RS with ground measurement and inventory is recommended to provide a holistic view of how the ecosystem works through time within the 2 areas, the natural forest and the forest rehabilitation area. With the updated land cover baseline information, we can actually model the carbon storage of the area. Carbon accounting is an important global consideration since it determines the capacity of the terrestrial ecosystems to regulate the concentration of greenhouse gases such as carbon in the atmosphere that causes global warming. With this, the Integrated Valuation of Ecosystem Services and Trade-offs, or INVEST model, was selected for this study, which uses an allometric model and field-based measurements to estimate carbon stocks through non-destructive and cost-effective approach. For each land cover class, an estimate of the 4 carbon pools was determined using a literature review in the Philippines. These carbon pools are the following: above ground carbon, or AGC, below ground carbon, or BGC, dead organic matter carbon, or DOMC, and soil organic carbon, or SOC. Studies of Almarines, Leonard's, and Lasco were used to estimate total carbon stock in the mining area. Based on the model simulation, the estimated total carbon stock in megagram in FCF site is around 736,444.14, reported as the sum of all these carbon pools. Largest carbon stock is stored in soil organic matter and above ground biomass, which is estimated to store around 35% and 32% respectively. These large portions of AGC and SOC is due to the presence of large tracts of forest or vegetation in the site, which accounts for approximately 2/3 of the total area. Proper monitoring of forest and vegetation loss needs to be implemented to make sure that important sources of carbon sinks are maintained. Based on the assessment of Lasco and his colleague in 2000, natural vegetation, in general, sequesters around 0.92 tons of carbon per hectare per year. With these, it can be estimated that FCF forests, estimated at 2,264 hectares, can potentially sequester around 2,083 megagrams of carbon per year. On the other hand, brushlands, with a potential carbon sequestration rate of around 4.29 tons of carbon per hectare per year, can sequester around 1,240 megagrams of carbon per year. These are valuable carbon pools that need to be protected and maintained if there are plans to venture into carbon credits and market. Brown and Pulhin used equations applied on a monitoring plot level to estimate biomass in Region 2, Philippines. Their results show that the total carbon storage of the natural forest plot is estimated at around 194,968 kilograms. Continuous monitoring of the plot is crucial to determine the carbon sequestration potential of that said plot. To efficiently monitor the success of rehabilitation and forest protection initiatives within the FCF project site, other remote sensing techniques can be used. Using Normalized Difference Vegetation Index, also known as NDVI, derived from Landsat 8 satellite imageries, we can determine trends in vegetation density in the area. Time series information in the rehabilitation plot shows a considerable positive trend, a 5-fold increase ranging from 0.1 to 0.6 in NDVI values indicates that there is an increase in vegetation presence over a 7-year monitoring period. On the other hand, there is a stable time series signal in the natural forest plot with minimal fluctuations in the magnitude of plus-minus 0.2, suggesting a minimal disturbance or undisturbed state. Fluctuations in the NDVI signal in the natural forest plot can be attributed to the influence of the wet and dry season in Region 2. With a wide range of options to utilize remote sensing data, both optical and radar images, combined with data science methods, suggests an opportunity to develop systems to monitor vegetation conditions in the mining site.